Interactive visualizations are aimed at engaging users in explorative and sense-making activities. They have been widely used in 2D display types such as PC and tablet. Virtual reality, as an emergent technology, is designed to have a greater level of engagement because of its immersive display. Thus, the evaluation of the interactive visualizations in VR could be important to frame the design of visualization tools in virtual reality systems.
To investigate this, we use 3D geometric shapes as testbed. From these three platonic-based solids, the cube, octahedron, and tetrahedron, it is possible to obtain a variety of other solids by truncating their vertices and edges. However, these properties of 3D solids are often hard to learn and explore because of their multi-layered relationships. There could be a feasible testbed to explore whether visualizations in VR are suitable exploratory tools.
To evaluate interactive visualizations in VR, we created VR-SVT, a tool which allows users to interact with these 3D solids. 5 visual interactive techniques were embedded within the tool with 2 indirect and 3 direct manipulation techniques.
The first technique is STM, Solid Transition Maps. They provide an overview and help visualize transitional processes between multiple stages of the shapes. Each STM incorporates thumbnails of possible transformation stages. 3 types of spatial knowledge are included in the maps: landmark, route, and survey. In the VR environment, the 3 maps are placed next to each other, and each map is put under its corresponding man shape. The 3 STM panels are interactable through the recasting technique. The second technique, dot manipulation, also known as semantic magnification, provides a direct and explicit interaction with the solids. The dot is synchronized with STM, which leads to a flexible and consistent interaction. Rotation and geometric magnification are critical to visualizations in 3D environment. In our tool, users can grab the shape and observe them from different perspectives, or to look at them closely. Finally, synchronization, or dynamic linking, automatically connect all shapes and STMs. This leads to a consistent and flexible interaction. It can be turned off when not preferred by users.
We conducted an experiment with 20 participants, 10 males and 10 females, from a local university. The whole experiment was divided into 6 phases. First, we introduced the mathematical and experiment background to participants. The participants were then asked to do a pretest. After that, they were allowed to interact with the tool for around 40 minutes and complete a set of predefined tasks. They then were asked to complete the questionnaire and the interview. Finally, they did the post-test.
Overall, the average score significantly increased by 20% from the pretest to post-test, with 25% for landmark knowledge, 22.5% for route knowledge, and 12.5% for survey knowledge. No significant difference was found between male and female participants. VR-SVT also received high engagement score from participants.
In this research, we found that the interactive visualizations in virtual reality systems can be supportive of exploration and analytical reasoning tasks. In contrast to previous studies, our results have revealed that the interactive visualizations in VR could lead to positive learning outcome even with much shorter exploration time. This is important because the prolonged use of VR may lead to visual or physical fatigue and motion sickness.
According to participants' performance in each spatial knowledge category, it is clear that VR could be especially helpful for visualizing structural and transformational properties of 3D visualizations. On the other hand, because of the limited field of view of current VR head-mounted displays, exploring multiple visualizations in VR can be challenging.
In terms of how participants want to interact with visualizations, we found that the techniques that are based on direct manipulation have been generally more favored and frequently used by participants as compared to indirect ones. These findings suggest that the direct manipulation could be emphasized to promote positive user visualization engagement.
We also propose some possible directions for future work.